August 1943, Quebec City, Canada, the Château Frontenac Hotel. Inside a heavily guarded conference room, the most powerful military leaders in the Allied world had gathered. Winston Churchill, Franklin D. Roosevelt, the combined chiefs of staff, admirals, generals, air marshals. They were deciding the future of World War II. Suddenly, 2 gunshots rang out. Guards burst through the doors, fearing assassination. What they found was even stranger. Lord Louis Mountbatten stood holding a service pistol. On the floor, 2 blocks, one shattered into fragments, the other perfectly intact, with a bullet ricochet mark, and Admiral Ernest King examining his trouser leg, where a bullet had just grazed past. "Gentlemen," Mountbatten announced calmly, "may I present Pykrete?" Nobody in that room could have imagined that this demonstration would lead to one of the most audacious engineering proposals in history, a ship made entirely of ice, 2,000 feet long, bigger than any vessel ever built, an aircraft carrier that could carry 300 planes, unsinkable, self-repairing, nearly indestructible. They laughed, they called it mad, they dismissed it as impossible. But for 8 months, thousands of people worked to make it real. A prototype was built, plans were drawn, Churchill and Roosevelt approved it. This is the story of Project Habbakuk, the ice ship that almost changed naval warfare forever. The brilliant idea that was simultaneously genius and insane, the weapon that could have won the Battle of the Atlantic, if only it hadn't been completely impractical. The problem nobody could solve. March 1942. The Battle of the Atlantic was going very badly for the Allies. German U-boats ruled the mid-Atlantic. The Atlantic Gap, a zone beyond the range of land-based aircraft. No air cover, no protection, just merchant ships and the submarines hunting them. In 1942 alone, U-boats sank 1,006 Allied ships, over 6 million tons of shipping. Food supplies to Britain threatened, war materials lost, oil tankers destroyed. The convoys were helpless. Naval escorts could fight submarines, but they couldn't see them coming, couldn't hunt them down, couldn't protect every ship. What the Allies needed desperately were aircraft carriers in the mid-Atlantic, planes that could patrol, spot submarines, attack them before they struck. But there was a problem. Aircraft carriers were scarce, they took years to build, required enormous amounts of steel, were desperately needed in the Pacific. Britain had maybe a dozen carriers. Most were small. None could be spared for convoy duty. The United States was building carriers fast, but they went to fight Japan. The Essex-class program consumed all available resources. There was no solution. The Atlantic Gap remained. U-boats continued killing. Unless someone came up with something radical, something unconventional, something nobody else would dare propose. Enter Geoffrey Pyke, the genius nobody could stand. Geoffrey Nathaniel Joseph Pyke was born November 9, 1893, in London. He was, by all accounts, brilliant, also eccentric, impossible, maddening. He attended Cambridge but never completed his degree. During World War I, he snuck into Germany as a journalist, was captured, imprisoned in an escape-proof camp, escaped anyway, became a war hero. After the war, he became rich on the stock market, then lost everything in the 1927 crash, went bankrupt. His wife left him. He fell into depression. For years he survived on donations from friends, lived in squalor, stopped bathing regularly, dressed in shabby clothes, let his beard grow wild. But his mind never stopped. In 1942, Pyke worked for Combined Operations Headquarters, a British military department developing unconventional warfare tactics. Lord Louis Mountbatten led Combined Operations. He tolerated Pyke's eccentricities because Pyke had ideas, strange ideas. Brilliant ideas. Ideas that just might work. Pyke had already proposed the Weasel, a small tracked vehicle for snow operations. It worked. He'd proposed commando raids using specialized equipment. They succeeded. Mountbatten called Pyke the most unusual and provocative man I have ever met. Others were less charitable. Clothed commonplace ideas with pseudo-scientific blather. Pretentious nonsense. A man of vivid and uncontrollable imagination. But nobody denied he was thinking about the Atlantic problem. The idea nobody believed. Sometime in 1942, Pyke was mulling over the aircraft carrier shortage. Steel was scarce. Shipyards were overwhelmed. Construction took years. What if you didn't need steel? What if you could build a ship from something abundant, something free, something available everywhere? Ice. The idea wasn't entirely original. German scientist Dr. Gerck had experimented with ice platforms in Lake Zurich in 1930. Churchill himself had mused about using icebergs as mid-Atlantic refueling platforms. But Pyke took it further. Not a modified iceberg, a purpose-built ship, constructed entirely from ice. The advantages were obvious. Ice was free, available in unlimited quantities, could be shaped to any form, would float naturally. But ice had problems. It was brittle, shattered on impact. It melted. It turned and rolled like icebergs do. You couldn't build anything practical from it, unless you could make ice stronger. The material nobody had heard of February 1943. Pyke learned about research by Hermann Mark and Walter Hohenstein. They'd discovered something remarkable. If you mixed wood pulp into water before freezing it, the resulting ice was completely different, stronger, tougher, non-brittle. The wood fibers acted like reinforcement, like rebar in concrete. The fibers prevented cracking, distributed stress, held the structure together. Pyke had Mark's report sent to Max Perutz, a young scientist who would later win the Nobel Prize. Perutz set up experiments in an unlikely location, the Smithfield Meat Market in London, behind a screen of hanging animal carcasses, completely secret. Perutz tested various mixtures, 4% wood pulp and 96% water, 8% wood pulp, 14% wood pulp. The results were astounding. The mixture was as strong as concrete, weight for weight. A bullet fired at it didn't penetrate, it bounced off. Unlike ordinary ice, it didn't shatter when struck. It absorbed impacts. Self-sealed minor damage. Could be repaired by simply adding more mixture and freezing. Perutz's tests showed crushing strength around 100 pounds per square inch. A .303 caliber bullet penetrated only 6.5 inches. Compare that to pure ice, which shattered completely. They named the material Pykrete, after its inventor, and because it was concrete-like. Pyke was ecstatic. This was the breakthrough. Ice that behaved like structural material. Ice you could build ships from. The demonstration nobody expected Mountbatten needed to be convinced. Pyke prepared a demonstration. According to legend, possibly apocryphal, Pyke burst into Churchill's bathroom while the Prime Minister was bathing. He dropped a block of Pykrete into the hot bath water. Churchill stared at it. Mountbatten joined him. They waited. Minutes passed. The Pykrete barely melted. The outer surface formed an insulating layer of wood pulp, prevented further melting. The block could sit in hot water for hours, largely unchanged. Churchill was convinced. A more formal demonstration occurred at Combined Operations Headquarters. Lieutenant Commander Douglas Grant conducted it. He had 2 blocks. 1, ordinary ice. 1, Pykrete. Grant warned everyone about splinters, then fired a pistol at the ice block. It exploded into fragments. Then he fired at the Pykrete. The bullet ricocheted, hit the Chief of the Imperial General Staff, Sir Alan Brooke, in the shoulder. Brooke was unhurt, but startled. Everyone was impressed. This material was real. The proposal nobody thought was sane. September 1942, Pike wrote a 232-page memorandum, sent it to Mountbatten. The document outlined his complete vision. A ship, no, a floating island, length 2,000 feet, 610 meters, width 300 feet, 91 meters, depth 200 feet, 61 meters, displacement 2.2 million tons. For comparison, the RMS Queen Elizabeth, the world's largest liner, displaced 83,600 tons. The largest aircraft carrier in 1943 was maybe 30,000 tons. Pike's ice ship would be 70 times larger. The hull would be 40 feet thick. Pure Pykrete. 40 feet. Torpedoes would hit it and barely penetrate. A few feet into 40-foot walls. The damage could be repaired by mixing Pykrete and freezing it in place. Self-healing ship. It would carry 300 aircraft, not small fighters. Full-size bombers. Heavy fighters. Reconnaissance planes. The flight deck would be 2,000 feet long, longer than any existing carrier. Planes that couldn't operate from conventional carriers could use Habbakuk. Armament, enough anti-aircraft guns to defend against bomber attacks. Engines, 26 electric motors. Top speed, 7 knots, 8 mintepa. Range, 7,000 miles. Crew, 3,620 men. The ship would need refrigeration. A massive system of pipes throughout the hull, circulating cold brine, keeping the Pykrete frozen, preventing melting. Even in warm water, the thick insulation and refrigeration would work. The ship could operate in the Atlantic, even in summer. Pike named it Habbakuk, a biblical reference from the prophet Habbakuk. Be utterly amazed, for I am going to do something in your days that you would not believe, even if you were told. Perfect. The support. Nobody anticipated Churchill loved it. The audacity. The scale. The sheer impossibility made possible. Mountbatten championed it enthusiastically. This was exactly the kind of unconventional thinking combined operations encouraged. The timing was crucial. Mid-1943. The Battle of the Atlantic was reaching crisis point. U-boat losses were mounting, but so were Allied ship sinkings. Something had to change. Churchill approved the project on December 4, 1942. The memo was classified most secret. He ordered a prototype built. But Britain lacked the resources, facilities, cold climate, labour. So they turned to Canada. The prototype nobody would forget, Dr. C.J. Mackenzie led Canada's National Research Council. He received the Habbakuk proposal. His reaction, another of those mad, wild schemes. But orders were orders. Mackenzie began planning. Location chosen, Patricia Lake. Jasper National Park, Alberta, remote, cold, already closed to the public for military ski training, near railroad facilities. Labour source, conscientious objectors, men who refused to fight but were willing to do non-combat work. They were never told what they were building, just a special project. Construction began February 1943. The goal, a scale model, 1/50th the size of the full ship, 60 feet long, 30 feet wide, 1,000 tons. They cleared a section of frozen lake, built wooden framing, started laying ice. The first plan was to use pure lake ice, cut it into blocks, stack them. This proved the concept, but showed pure ice's limitations. Not strong enough, too brittle. Then Pykrete was introduced. The difference was immediate. Superior strength, better integrity, actual structural potential. The prototype had a cooling system, a 1-horsepower motor circulating air, pipes throughout the structure, crude but functional. The entire structure was covered by a roof, looked like a boathouse from outside. Complete secrecy maintained. By summer 1943, the prototype was complete, 60 feet long, It floated. It worked. Well, sort of. The problems nobody could fix. Even during construction, issues emerged. Problem 1, the cooling system. The full-scale Habbakuk would need a massive refrigeration plant, thousands of miles of piping, enormous compressors, constant power. Engineers calculated the steel required for refrigeration. It was more than the steel needed to build a conventional carrier. The whole point was to save steel. This defeated the purpose. Problem 2, the flight deck. You couldn't land aircraft on ice. Too slippery, too cold, would freeze aircraft systems. So you needed a conventional flight deck, wood or steel. That added weight, complexity, cost. The Royal Navy also demanded the deck be 2,000 feet long to accommodate heavy bombers. That made the ship even larger, even more expensive. Problem 3, steering. Pike's original plan, vary motor speed on either side, like a tank. Turn by making one side go faster. The Royal Navy insisted on a proper rudder. For a ship this size, the rudder would be over 100 feet tall. Mounting it, controlling it, making it work in a Pykrete hull. Nobody solved this. Ever. Problem 4, wood pulp requirements. For one ship, 300,000 tons of wood pulp. That was enough to affect paper production significantly. Newspapers, documents, critical war materials, all competing for the same pulp. Problem 5, insulation. Each ship would need 35,000 tons of cork insulation. Cork was already scarce, used for life jackets, gaskets, other essential purposes. Problem 6, construction time and labour. Pike claimed 14 days to build. Wildly optimistic. Realistic estimates, months, maybe a year, requiring 35,000 workers during wartime, when labour was desperately needed everywhere. Problem 7, cost. Initial estimate $700,000, then $2.5 million, then over $10 million for one ship. That could build multiple conventional carriers. The conference nobody believed, August 1943, Quebec Conference. Churchill and Roosevelt met to plan Allied strategy. Mountbatten brought his Pykrete demonstration, 2 blocks, 1 ice, 1 Pykrete, his service pistol. First shot, ice block, shattered spectacularly. Everyone expected that. Second shot, Pykrete. The bullet ricocheted, grazed Admiral Ernest King's trouser leg, lodged in the wall. According to some accounts, King was not impressed by the unorthodox demonstration. According to others, he was fascinated. The demonstration certainly got attention, but attention wasn't the problem. By August 1943, the strategic situation had changed. The alternatives. Nobody considered earlier 3 developments made Habbakuk less necessary. First, Portugal allowed Britain to use airfields in the Azores, mid-Atlantic bases, exactly where they were needed. Land-based aircraft could now patrol the Atlantic Gap. Second, long-range fuel tanks. The consolidated B-24 Liberator with extended fuel tanks could patrol 2,300 miles from base, covered much of the Atlantic Gap. Third, escort carriers. The US was mass-producing small carriers, converted merchant ships, not as capable as fleet carriers, but good enough for convoy escort, much cheaper than Habbakuk, much faster to build. By mid-1943, the Battle of the Atlantic was turning. U-boat losses were mounting, new tactics, better radar, more escorts, more aircraft. The crisis that spawned Habbakuk was easing. The meeting nobody wanted to attend, December 1943, the final Habbakuk board meeting. Mackenzie reported from Canada. The prototype worked, but scaling up would be enormously expensive, technically challenging, resource-intensive. Mountbatten had withdrawn support. The strategic need had passed. The technical problems were insurmountable. Better alternatives existed. the official conclusion. The large Habbakuk II made of Pykrete has been found to be impractical because of the enormous production resources required and technical difficulties involved. Project Habbakuk was cancelled. The prototype on Patricia Lake was abandoned, left to melt. It took 3 hot Canadian summers, 3 full summers for 1,000 tons of Pykrete to melt completely. That's how durable it was. A full-scale Habbakuk might have lasted decades, but it would never be built. The wreckage nobody removed today, Patricia Lake in Jasper National Park, holds a secret. 50 feet below the surface, the remains of Project Habbakuk, not the ice. That melted long ago. But the metal components, pipes, framing, refrigeration equipment, divers can visit the wreckage. A commemorative plaque marks the site on shore, a reminder of one of Canada's strangest wartime projects. Most people walking past the lake have no idea that beneath the peaceful water lies the remnant of a ship that almost changed history. The inventor, nobody remembered. Geoffrey Pyke continued working during the war. Other unconventional ideas. Most went nowhere. After the war, he worked on planning for the National Health Service, tried to model how Britain would pay for it, broadcast ideas on the BBC, but depression consumed him. His brilliant ideas were ridiculed in the press. The mad boffin. Ludicrous schemes. Distance from reality. He felt discredited, humiliated, lost. He'd also been under MI5 surveillance, suspected of being a Soviet agent. Codenamed Professor P, whether this was true remains debated. On the evening of Saturday, February 21st, 1948, Pyke shaved his beard, wrote private letters, consumed a bottle of sleeping pills. His landlady found his body Monday morning. The coroner ruled suicide at a moment of mental unbalance. Geoffrey Pyke was 54 years old. The Times obituary praised him. The death of Geoffrey Pyke removes one of the most original, if unrecognized, figures of the present century. He remained always the knight-errant, from time to time gathering round him a small band of followers, but never a leader of big movements. Because of the very greatness of his ideas, most of his life was one of frustration and disappointment. But he has left behind to all who knew him and were indirectly affected by him the vision he created for making all things possible. Most people had already forgotten him. And Project Habbakuk. The science nobody questioned, but Pykrete was real. The science was sound. In 2009, the TV show Mythbusters tested Pykrete. They confirmed it's much stronger than pure ice, hundreds of pounds of weight, impact resistance, bullet resistance. They even built a boat from super Pykrete, using shredded newspaper instead of wood pulp. They called it Yesterday's News. It floated. It worked. In warm water. Pykrete wasn't fantasy. It was genuine material science, just not practical for ship construction. The alternatives nobody built after Habbakuk's cancellation, other floating island ideas were considered. Project Tentacle, weld Liberty ships together, create floating platforms. This was actually more practical, still never built. The reality was simpler, better aircraft, more carriers, better tactics. Won the Battle of the Atlantic, no ice ships required. The specifications nobody could meet. Let's be clear about what Habbakuk would have been. Dimensions, length, 2,000 feet, 600 meters. Width, 300 feet, 91 meters. Depth, 200 feet, 61 meters. Draft, 150 feet, 46 meters. Displacement, 2.2 million tons. Construction, hull, 40-foot thick Pykrete walls, 300,000 tons of wood pulp required, 35,000 tons of cork insulation, thousands of miles of refrigeration piping, 4 power stations for refrigeration. Propulsion, 26 electric motors. Maximum speed, 7 knots, 8 meter much. incredibly slow. A walking person could almost keep up. Range, 7,000 miles. Fuel capacity, 5,000 tons. Daily consumption, 120 tons. Aircraft capacity, 200 Spitfire fighters, OR, 100 mosquito bombers. Full operational and repair facilities, 2,000-foot flight deck. Crew, 404 officers, 3,016 enlisted men. Total, 3,620. Armament, sufficient anti-aircraft guns for defence. Exact number never finalised. Cost, originally estimated $700,000. Revised estimate, $2.5 million. Final estimate, over 10 million dirham. Compared to a conventional carrier, cost, maybe 2 million down. Construction time, 2 years. Displacement, 30,000 tons. Speed, 30 plus knots. Habbakuk was 70 times heavier, 4 times slower, 5 times more expensive, but it was unsinkable, self-repairing, could operate indefinitely in the Atlantic. If only they could actually build it. The reasons nobody disputed. Why did Habbakuk fail? Not because the science was wrong. Pykrete worked. The prototype proved the concept, not because the need wasn't real. The Atlantic gap was killing Allied shipping. It failed because of practicality. Reason 1. Resource requirements exceeded benefits. The steel for refrigeration alone exceeded what was needed for conventional carriers. The wood pulp would affect war production. The labour and facilities were better used elsewhere. Reason 2. Technology overtook the concept. By the time Habbakuk could be built, long-range aircraft solved the problem. Faster, cheaper, more flexible. Reason 3. Strategic situation changed. By late 1943, the Allies were winning the Atlantic. The crisis had passed. The desperate need that justified desperate measures no longer existed. Reason 4. Technical problems were insurmountable. The rudder issue was never solved. The cooling requirements kept growing. Construction challenges multiplied. Reason 5. Better alternatives existed. Escort carriers could be built in months. They were faster, more maneuverable, nearly as effective. Habbakuk was brilliant in concept, impractical in execution. The legacy nobody expected Project Habbakuk left several legacies. First, it showed that unconventional thinking matters in warfare. Sometimes the craziest ideas are worth exploring. Sometimes they lead nowhere, but sometimes they spark innovations. Second, it demonstrated material science possibilities. Pykrete itself went nowhere, but composite materials became crucial. Reinforced plastics, carbon fibre, fiberglass, all use the same principle. Combine materials to get properties neither has alone. Third, it proved that even brilliant ideas can fail for practical reasons. Engineering isn't just about what's possible, it's about what's practical, cost-effective, achievable with available resources. Fourth, it became a legend. The ice ship, the floating iceberg carrier, one of World War II's strangest proposals, books written about it, documentaries made, persistent fascination, because it's such a perfect example of wartime desperation, breeding innovation, and innovation sometimes exceeding sanity. The demonstration that became legend. The Quebec Conference demonstration became famous. Mountbatten shooting Pykrete, the bullet ricocheting, nearly hitting an admiral. Different accounts give different details. Some say it was Admiral Ernest King. Some say it happened earlier in London to Sir Alan Brooke. Some say the bullet actually hit Brooke in the shoulder. He was unhurt. Some say it just grazed King's trouser leg. Peruzzi's account suggested the London incident was real. The Quebec incident might have been Mountbatten retelling the story, embellished, for dramatic effect. What's certain? Bullets did ricochet off Pykrete blocks. The demonstrations happened. They impressed people. The image of a military officer firing a pistol in a high-level conference, a bullet bouncing around the room, admirals and generals diving for cover. It's too good not to retell, even if the details vary. The ship that never was. Imagine if they'd built it. Imagine Habbakuk floating in the mid-Atlantic, 2,000 feet of white ice and wood pulp, sprouting anti-aircraft guns, aircraft launching from its massive deck, looking like nothing that had ever sailed, torpedoes hitting the hull, blowing chunks of Pykrete off, crews repairing the damage with seawater and wood pulp, freezing it in place, operating for months, years maybe, slowly melting, slowly being repaired, unsinkable, unstoppable, hunting U-boats, protecting convoys, controlling the Atlantic. It would have been the most remarkable vessel in naval history, stranger than any science fiction, more audacious than any battleship. But it was never built, and maybe that's better, because Habbakuk represents something important. Not every brilliant idea should be realized. Not every problem requires a radical solution. Sometimes the conventional approach is better. More aircraft, more carriers, better tactics. These won the Atlantic, not ice ships. The question nobody asks. Could we build Habbakuk today? Technically, absolutely. Modern refrigeration technology, advanced composite materials, computer-aided design, massive construction capabilities, it would still be expensive, still be impractical, still be unnecessary. But we could do it. The real question, should we? And the answer is no. Modern aircraft carriers are nuclear-powered, travel at 30-plus knots, carry 80-plus aircraft, operate globally, cost billions. They're far superior to a slow-moving ice platform. But Habbakuk wasn't about superiority. It was about desperation, about solving an impossible problem with available resources. Ice was free. Wood pulp was abundant. Pykrete was strong. In 1943, those facts mattered. In the 21st century, they don't. The truth nobody disputes: Geoffrey Pyke was brilliant, eccentric, difficult, visionary. Project Habbakuk was audacious, scientifically sound, practically impossible. The prototype worked, the concept was proven, the ship was never built, and the Battle of the Atlantic was won without it. But the story endures, because it's the perfect example of wartime innovation, when desperate times demanded desperate measures, when conventional wisdom was abandoned, when someone asked, "What if?" and nearly built an aircraft carrier from ice. They laughed at the ice ship, called it mad, dismissed it as fantasy. Until they saw the demonstrations, until they understood the science, until Churchill himself approved it. It almost carried bombers over the Atlantic. It almost became the largest ship ever built. It almost changed naval warfare. Almost. But almost is enough for legend. The ice ship that never was. The floating island that stayed on paper. The unsinkable carrier that melted away. Project Habbakuk. Born from desperation. Built on science. Killed by practicality. A monument to human ingenuity and human limitations. At the bottom of Patricia Lake, the wreckage remains. Pipes and metal. Ghosts of an impossible dream. A reminder that sometimes the craziest ideas are worth exploring, even if they never leave the drawing board, even if they melt away, even if nobody remembers the genius who conceived them. Geoffrey Pyke died forgotten. Project Habbakuk became a footnote. The ice ship became a legend. And somewhere in the Canadian Rockies, beneath cold, clear water, the evidence still sits that once, just once, someone tried to build an aircraft carrier from ice, and it almost worked. The scientist nobody would forget, Max Perutz, deserves his own chapter in this story. Born in Vienna in 1914, came to Cambridge in 1936 to study hemoglobin structure. specialized in glaciology and ice crystal structures. When Pyke needed someone to test ice reinforcement, Pykrete was the perfect choice. He understood ice at the molecular level, how crystals formed, how they broke, how they could be modified. His laboratory was the Smithfield Meat Market, behind hanging beef carcasses. In refrigerated rooms meant for storing meat, perfect temperature, perfect secrecy. Pykrete conducted systematic experiments, different percentages of wood pulp, different types of fibers, different freezing methods. He tested mechanical properties, compression strength, tensile strength, impact resistance, bullet penetration. He discovered the optimal mixture, 14% wood pulp, 86% water by weight. This ratio produced the best balance of strength and workability. The wood fibers acted as microscopic reinforcement, like rebar in concrete. When stress caused the ice to crack, the fibers bridged the gaps, prevented catastrophic failure, distributed loads across the structure. Pykrete measured crushing strength, 1/100 psi. For comparison, concrete, 2,500-5,000 PLNC. Pykrete wasn't as strong as concrete pound for pound. But it was close, and ice was free. He found that Pykrete's strength increased at lower temperatures. At 15 degrees Celsius, it was significantly stronger than at 0 degrees Celsius, 32 degrees Celsius. The ship's refrigeration would need to maintain very cold temperatures, not just below freezing, but well below freezing. Pykrete also discovered Pykrete's limitations. It sagged under sustained pressure, plastic deformation over time. This meant structural elements couldn't be too long without support. Beams would bend, floors would warp. But for thick hull walls, this wasn't a problem. The mass was self-supporting. 40-foot thick walls wouldn't sag significantly. Pykrete's work was meticulous, scientific, thorough. He provided the data that made Habbakuk seem feasible. After the war, he won the Nobel Prize in Chemistry in 1962 for determining the structure of hemoglobin. But in 1943, he was making ice stronger. The construction nobody understood. Patricia Lake construction began February 1943. Winter in the Canadian Rockies. Temperatures well below freezing. Perfect conditions. The site was chosen carefully. The lake was already closed to the public, used for military ski paratrooper training. Security was tight. Railway facilities were nearby. Materials could be shipped in. Workers could be transported. The labor force was unusual. Conscientious objectors, men who refused military service for religious or moral reasons, but willing to do civilian war work. They lived in a nearby camp, were paid modest wages, worked long hours in brutal cold. They were never told what they were building. Just a special military project, classified, secret, important. The construction process was complex. First, they cleared a section of frozen lake surface, swept away snow, created a flat platform. Then they built wooden framing, timbers bolted together, creating the basic shape, 60 feet long, 30 feet wide. Then they laid flooring, wooden planks, supporting the initial ice layers. The roof went up early, creating a giant boathouse structure. This served multiple purposes: protected the ice from sun, concealed the work, allowed heating for workers, but not the ice. Initial construction used lake ice. Workers cut blocks from the lake. Each block weighed hundreds of pounds, lifted manually, stacked carefully. This phase demonstrated immediate problems. Pure ice was heavy, but fragile. Cracked under its own weight, didn't bond well between layers. When Pykrete was introduced, everything changed. They mixed wood pulp with water, poured it into molds, let it freeze. The Pykrete could be shaped, moulded, formed to specific dimensions, layers bonded together, creating monolithic structure, much stronger than stacked ice blocks. The refrigeration system was primitive, but functional. A 1-horsepower electric motor circulated cold air through the structure, simple pipes, basic insulation. It worked. The Pykrete stayed frozen, even as spring approached. By June 1943, the prototype was complete. 1,000 tons of Pykrete and wood floating in Patricia Lake, proving the concept. Workers celebrated. They'd built something unprecedented, a floating structure of ice. That didn't melt. That could support weight. That actually worked. Dr. Mackenzie inspected it personally. He was impressed, but also concerned. The full-scale version would be 2,000 times larger. The complexity would multiply exponentially. The numbers, nobody could ignore. Let's examine the full-scale Habbakuk's requirements in detail. Pykrete volume, hull, 2000 ft x 300 ft x 40 ft thick walls, plus deck and bottom. Total volume, approximately 50 million cubic feet. Weight, about 2 million tons. Wood pulp requirements, 14% of 2 million tons, 280,000 tons of wood pulp. That's enough to make newspapers for the entire British Empire for weeks. In wartime, when paper was already rationed. Steel requirements, refrigeration piping, thousands of miles. Estimate, 40,000 tons just for cooling pipes. Structural reinforcement, additional 20,000 tons. Flight deck, 10,000 tons. Total, 70,000 plus tons of steel. A conventional Essex-class carrier used about 20,000 tons of steel total. Habbakuk would use 3.5 times more steel, just for systems, not counting the ice. Labour requirements. Construction crew. Estimated 35,000 workers. Construction time. 8-12 months, optimistically. Compare to conventional carrier, 2,000 workers, 24 months. Habbakuk required more workers, though less time. But where would 35,000 workers come from? In 1943, every able-bodied person was already doing war work. Power requirements, 4 power stations for refrigeration, each producing megawatts of power. Constant operation. Enormous fuel consumption. 26 electric motors for propulsion. More power for lights, equipment, aircraft operations. Daily fuel consumption, 120 tons, compared to conventional carrier, 20 tons. Operating costs would be enormous. The variants nobody selected naval architects developed 3 alternatives, presented in August 1943. Habbakuk 1, made of wood, not Pykrete, basically a giant wooden barge, quickly discarded. Wood alone wasn't strong enough, would require too much timber. Habbakuk 2, closest to original concept, huge Pykrete vessel, 2,000 feet long, very slow, 7 knots, self-propelled. This was the official Habbakuk, the one Churchill wanted, the one that was never built. Habbakuk III, smaller, faster version, maybe 1,000 feet long, designed for higher speed, 10-12 knots. Less aircraft capacity, still Pykrete construction. This was the practical compromise, still enormous, still expensive. But maybe achievable. None were selected. The whole project was too problematic. The weapons nobody designed Habbakuk would need defensive armament. Anti-aircraft guns primarily. But which guns? How many? This was never fully resolved. British planners suggested multiple quad 40mm Bofors mounts, dozens of 20mm Oerlikon guns, possibly 5.25-inch dual-purpose guns, maybe 50-plus gun positions total. The ice structure created interesting possibilities. You could blast gun positions directly into the Pykrete, create protected emplacements, integrated into the hull. Ammunition storage would be simple. Dig magazines into the ice. Naturally refrigerated. Explosion-proof. 40-foot thick walls. But there were problems. Firing heavy guns creates vibration. Would the Pykrete structure absorb it? Or would guns crack the hull? Nobody tested this. The prototype had no weapons. For aircraft operations, Habbakuk would need aircraft elevators, hangar decks, fuel storage, ammunition magazines, repair facilities, crew quarters. All of this would be built into or on top of the ice, some inside the hull, some on the deck. The engineering was complex. How do you attach steel structures to ice? How do you prevent thermal transfer? How do you maintain watertight integrity? These questions were being studied, but never fully answered. The timeline nobody believed Pike claimed Habbakuk could be built in 14 days. This was fantasy, pure fantasy. Realistic timeline, site preparation, 2 months. Initial construction, 4 to 6 months. Systems installation, 3-4 months. Testing and commissioning, 2 months. Total, 11 to 14 months minimum. This assumed perfect conditions. No delays. Unlimited resources, ideal weather. In reality, it would probably take 18 to 24 months, maybe longer. Construction would need to begin in winter. Take advantage of cold temperatures. Reduce refrigeration requirements during building. Launch would be in spring or early summer. Float it before full melting risk. The ship would need constant maintenance. The refrigeration system could never stop, never shut down. Continuous operation, 24/7. What if the refrigeration failed? Backup systems would be essential. Multiple redundant cooling loops. Emergency generators. But if refrigeration failed completely, the ship would start melting, slowly at first, then accelerating. In warm water, even with 40-foot walls, complete melting might take weeks, maybe a month. Time to evacuate, abandon ship, but the ship itself would be gone. 2.2 million tons of Pykrete returning to the ocean. The comparison nobody made. Let's compare Habbakuk to other Wobby-Woud mega projects. Manhattan Project, atomic bomb, cost $2,019,45. Workers, 130,000 at peak, duration 3 years. Result, war-ending weapon, success, total. Habbakuk, estimated cost, $10 million, $40 million, 1943. Workers needed, 35,000. Duration, 12 to 18 months. Result, 1 aircraft carrier. Success, never attempted. The Manhattan Project was 50 times more expensive. Used 4 times more workers. Took longer, but it ended the war. Habbakuk would have helped win the Atlantic, maybe. Other comparisons, Liberty ships, 2,700 built during the war. Each cost $2 million, built in 40 to 60 days. Simple, practical, effective. Essex-class carriers, 24 built. Each cost $60 million, built in 18 to 24 months. War winners. B-29 Super Fortress program, $3 billion, more than Manhattan Project. Built 3,900 aircraft, strategic game changer. Habbakuk was expensive for what it offered. 1 ship, very limited capability, enormous resource consumption. It's easy to see why it was cancelled. The context. Nobody remembers 1943 was the peak year for Allied mobilization. Everything was being tried, conventional and unconventional. Some wild ideas that worked. Mulberry harbours, artificial ports for D-Day, gigantic, revolutionary, worked perfectly. Pluto pipeline, fuel pipeline under English Channel. Crazy idea. Essential for invasion. Success. Proximity fuses. Radar-guided artillery shells. Game-changing technology. Won battles. Some wild ideas that failed. Panjandrum, rocket-propelled beach clearing device. Uncontrollable, dangerous, abandoned. Great Panjandrum, even crazier version. Same result. Ice ships weren't the only unusual idea. They were just the biggest. The difference? Mulberry harbours and Pluto solved specific, limited problems. Habbakuk tried to revolutionize naval warfare. Too ambitious. The cost. Nobody calculated beyond monetary cost. Habbakuk had opportunity costs. Every engineer working on Habbakuk wasn't working on better aircraft, better radar, better weapons, better conventional carriers. Every ton of wood pulp used for Pykrete wasn't available for newspapers, packaging, documents, cardboard. Every ton of steel in refrigeration wasn't available for more destroyers, more landing craft, more tanks, more aircraft. Wartime economics is about allocation, limited resources, unlimited needs. Choices matter. Habbakuk would have consumed resources, produced one ship, slow, limited capability, or those same resources could produce 3 escort carriers, or 10 destroyers, or 50 landing craft, or hundreds of aircraft. This was the real calculation. Not, can we build it? But, should we build it? And the answer was no. The melting nobody witnessed. After cancellation, the Patricia Lake prototype was abandoned. Summer 1943. The refrigeration was shut off. The structure exposed to summer sun. Workers expected it to melt quickly, maybe weeks, a month at most. They were wrong. Summer 1943, still substantially intact. Summer 1944, partially collapsed, but still present. Summer 1945, finally melted completely. 3 summers, 3 Canadian summers, to melt 1,000 tons. This was extraordinary. It proved Pykrete's durability, its resistance to melting, its longevity. A full-scale Habbakuk, properly insulated and refrigerated, could operate for years, maybe decades. But it didn't matter. The war was being won without it. The legacy that remains. Habbakuk failed, but the lessons endure. Lesson 1. Material science matters. Pykrete was real innovation. Composite materials became crucial post-war. The principle, reinforce weak materials with fibers, is everywhere now. Lesson 2. Unconventional thinking has value. Even failed ideas push boundaries, inspire new approaches, challenge assumptions. Lesson 3. Feasibility isn't just technical. Habbakuk was technically feasible. The prototype proved it, but practical, economic, strategic feasibility also matters. Lesson 4. Timing is everything. By the time Habbakuk could be built, it wasn't needed. Technology moved on. Better solutions emerged. Lesson 5. Desperation breeds innovation. The Atlantic Gap crisis drove creative thinking. Some ideas worked, escort carriers, some didn't, ice ships. Both were worth exploring. The modern parallel. Nobody expects today we face similar challenges. Climate change, resource scarcity, environmental crises. Some proposals are Habbakuk-like, technically feasible, practically questionable. Ocean fertilization to sequester carbon, giant space mirrors to cool Earth, artificial volcanoes for cooling, all are technically possible. All have enormous practical challenges. All might be unnecessary if simpler solutions work. The Habbakuk question remains relevant. Just because we can, should we? The truth that endures. Geoffrey Pike was a genius, eccentric, difficult, visionary. He saw solutions others missed, thought beyond conventional boundaries. Project Habbakuk was brilliant, audacious, scientific, impractical. The ice ship could have worked. The prototype proved it. The science was sound. The engineering was possible. But it was unnecessary. Better alternatives existed. Resources were better spent elsewhere. The Atlantic was won without it. And maybe that's the real lesson. Not every brilliant idea should be realized. Not every technical achievement is worth pursuing. Not every problem requires a revolutionary solution. Sometimes the conventional approach is better. Sometimes patience and incremental improvement win. Sometimes the ice ship should stay on paper. But we should never stop asking, what if? Never stop exploring impossible ideas. Never stop pushing boundaries. Because one day the impossible idea might be exactly what we need. The radical solution might be the only solution. The ice ship might be the answer. Just not in 1943, not in the Atlantic, not for aircraft carriers, but somewhere, sometime. Someone will read about Habbakuk, about Pykrete, about building ships from ice, and they'll think, what if we tried that for? And maybe, just maybe, it'll work. That's Geoffrey Pike's real legacy. Not the ship that wasn't built, but the idea that impossible is just a challenge, that creativity matters, that sometimes the craziest proposal is worth exploring. Even if it melts away, even if it never leaves the lake, even if everyone laughs. The ice ship taught us, dream bigger, think stranger, question everything, and never ever assume something can't be done, just because it hasn't been done. At the bottom of Patricia Lake, the wreckage remains. Pipes, timber, metal, ghosts of an impossible dream. Divers visit it, photograph it, wonder at it. And on the shore, a plaque reads a simple message, commemorating Project Habbakuk, the ice ship that almost was, a reminder that human ingenuity knows no bounds, that desperation breeds innovation, that failure teaches as much as success, and that sometimes the best stories are about things that never happened, ships that never sailed, weapons that never fired, dreams that melted away, but inspired us anyway. The scene nobody will forget. Let's return to that conference room in Quebec, August 1943, the Château Frontenac. The room was packed. Churchill, Roosevelt, General George Marshall, Admiral Ernest King, Air Chief Marshal Charles Portal, Field Marshal Alan Brooke, combined Chiefs of Staff, the most powerful military minds in the Allied world. They were exhausted. The war was grinding on. Africa was won. Sicily invaded. But the Atlantic was still dangerous. The Pacific was brutal. Europe awaited invasion. Then Lord Mountbatten requested the floor. He brought 2 blocks, placed them carefully. 1 ordinary ice, 1 Pykrete. "Gentlemen," he began, "we face the problem of the Atlantic Gap." Everyone knew it. The zone where U-boats hunted freely, where ships died, where aircraft couldn't reach. "I propose we build aircraft carriers from ice." The room went silent. Then murmurs, sceptical, dismissive, amused. Mountbatten continued, "Not ordinary ice, a special composite material. Pykrete." He explained the science. Wood pulp reinforcement, tremendous strength, self-repairing capability, unlimited raw materials. The murmurs grew louder. This was absurd. Ice ships? In the Atlantic? Preposterous. Mountbatten drew his service pistol. The room fell silent. "Allow me to demonstrate." He warned everyone about splinters. Aimed at the ordinary ice block. Fired. The block exploded. Ice fragments sprayed across the room, exactly as expected. Then Mountbatten turned to the Pykrete. "Now observe the difference," he fired. The bullet struck the Pykrete, didn't penetrate, ricocheted. Zipped across the room. Admiral King felt something brush his leg, looked down. A graze mark on his trouser. The bullet had passed inches from his knee. It embedded in the wall behind him. The room erupted. Shock, amazement, nervous laughter. "Good God, Mountbatten!" someone shouted. But everyone was impressed. The Pykrete hadn't shattered. The bullet had bounced off. This material was real. Churchill leaned forward, studied the Pykrete block, touched it. Cold, solid, unbroken. "How large a ship?" he asked. 2,000 feet, sir. 300 feet wide. Able to carry 300 aircraft. Roosevelt's eyebrows rose. 300? How many carriers would that replace? Potentially 10 conventional carriers, Mr. President, and unsinkable. The word hung in the air. Unsinkable. Everyone remembered the Titanic. Unsinkable was a dangerous word. But Pykrete was different. You couldn't sink ice. It floated naturally. Torpedoes would barely dent 40-foot walls. The discussion continued for hours. Costs, resources, feasibility, timeline. Churchill was enthusiastic. This was exactly his style. Bold, unconventional, game-changing. Roosevelt was cautious but intrigued. American Industrial might could build it, if anyone could. But Admiral King was skeptical. The US Navy was building conventional carriers, dozens of them, fast, proven, effective. Why divert resources to an unproven ice ship? The debate went late into the night. No final decision was made, but the project continued. For a while. The what if nobody answers. What if they'd built it? What if Habbakuk had sailed? Scenario 1. Success. Habbakuk launches spring 1944, sails to the mid-Atlantic, establishes station, aircraft patrol continuously, U-boats are spotted and attacked, sinkings drop dramatically. The Atlantic gap closes. Habbakuk is hailed as revolutionary. More ice ships are ordered. Naval warfare is transformed. Scenario 2. Qualified success. Habbakuk launches but faces problems. Refrigeration struggles in warm water. Speed is too slow for effective positioning. Aircraft operations are difficult on the ice deck, but it works well enough. Provides some protection to convoys. Supplements conventional carriers. War contribution is moderate. No additional ships are built. After the war, it's scrapped. Scenario 3. Disaster. Habbakuk launches successfully, but the cooling system has problems. Structural sagging develops. A storm strikes. The ship can't maneuver effectively. Damage occurs. Repairs are attempted, but the melting accelerates. Crew must be evacuated. The ship is abandoned. Melts away in weeks. The program is cancelled in embarrassment. Scenario 4. Never operational. Construction begins. Problems mount. Costs escalate. Resources are diverted. The project drags on for months, then years. By the time it might launch, the war is ending. It's abandoned, half-built. A monument to wartime excess. Which scenario was most likely? Probably scenario 2. It would have worked. Sort of. But not well enough to justify the cost. The Atlantic was being won anyway. Escort carriers were working. Long-range aircraft were working. Better tactics were working. Habbakuk would have been supplementary. Interesting. Unprecedented, but not war-winning. The numbers that tell the story. Let's look at what actually happened in the Atlantic. 1942, 1,006 Allied ships sunk. 1943, 463 ships sunk. 1944, 132 ships sunk. 1945, 56 ships sunk. What changed? More escorts, more aircraft, better radar, breaking German codes, new tactics. Escort carriers were crucial. Small carriers converted from merchant ships. Quick to build, cheap, effective. By 1944, escort carriers were everywhere, providing air cover, hunting submarines, protecting convoys. They weren't revolutionary. They weren't unsinkable. They weren't ice ships. But they worked. And that's what mattered. Habbakuk would have cost more than 10 escort carriers, taken longer to build, provided less coverage. The math didn't work. U-boat losses tell the story too. 1942, 87 U-boats sunk. 1943, 244 U-boats sunk. 1944, 249 U-boats sunk. 1945, 153 U-boats sunk. By 1943, the Allies were winning, killing submarines faster than Germany could build them. The Atlantic gap was closing. not because of ice ships, because of practical solutions, incremental improvements, conventional technology used cleverly. The cost of might have been Habbakuk consumed resources even though it was never built. Research and development, probably $500,000. Engineering studies, prototype construction, material testing, scientific research, labor hours, tens of thousands. Engineers designing, scientists testing, workers building the prototype, administrators coordinating, materials consumed, thousands of tons, wood for framing, ice for testing, steel for the prototype, fuel for transportation. Opportunity cost, incalculable. Every hour spent on Habbakuk. Was an hour not spent on something else? Was it worth it? Even though the ship was never built, the research had value. Understanding Pykrete, testing composite materials, exploring unconventional solutions. Some knowledge gained fed into other projects. Some techniques proved useful elsewhere. Some innovations had unexpected applications. That's the nature of research. Not everything has to succeed to justify the effort. Failure teaches. Exploration expands knowledge. Even dead ends provide information. But Habbakuk's legacy isn't technical. It's inspirational. It reminds us that we should think bigger, dream bolder, question assumptions. Not every wild idea succeeds. Not every brilliant concept is practical, but we should keep proposing them, keep exploring them, keep testing them, because one day, one wild idea will change everything, and we won't know which one, until we try. The memorial that should exist. There should be a monument to Project Habbakuk, not celebrating success, but honouring ambition. A statue of Geoffrey Pike, wild-bearded, dishevelled, brilliant, holding a block of Pykrete, looking toward the horizon, dreaming impossible dreams, or a memorial on Patricia Lake shore, more elaborate than the current plaque, telling the full story, or a museum exhibit with photographs, documents, a piece of Pykrete visitors can touch, because this story deserves to be remembered, not as a failure, but as an example of what humans can imagine. When pushed to the brink, when conventional solutions fail, when desperation demands innovation, we tried to build ships from ice, we almost succeeded, we learned, and that matters. The truth beneath the lake, at the bottom of Patricia Lake, in cold, dark water. The wreckage remains, metal pipes, wooden beams, rusted machinery, silent, forgotten, slowly decaying. Divers visit occasionally, photograph the remnants, wonder at the ambition. Imagine what stood there, 60 feet of white Pykrete, floating in mountain water, a miniature ice ship, proving the impossible. The ice is long gone, melted away decades ago, returned to the lake, became part of the water. But the metal remains, a ghost of what was, a shadow of what might have been. And that's fitting, because Habbakuk itself was always a ghost. A shadow of a ship that never truly existed, except on paper, in blueprints, in dreams. The metal at the bottom of Patricia Lake is the only physical evidence that anyone tried, and maybe that's enough. Maybe we don't need the ship. We need the attempt. We need the dream. We need the reminder that we can dream impossible things. We can attempt incredible feats. We can push boundaries, even if we fail, even if we melt away, even if we're forgotten. The attempt itself matters. The final word. They laughed at the ice ship until they saw it work. They built it until they didn't need to. They dreamed it until reality intervened. Project Habbakuk, the aircraft carrier made of ice, the ship that was too big, too slow, too expensive, too impractical, too late, but also too brilliant to dismiss. too innovative to ignore, too audacious to forget. Geoffrey Pyke died believing he'd failed, that his ideas were ridiculed, that his genius was wasted. He was wrong. His idea lives on, not in steel and ice, but in inspiration. Every engineer who thinks unconventionally, every scientist who questions assumptions, every innovator who proposes the impossible, they're all children of Habbakuk, heirs to Pyke's vision, carriers of the dream, that we can do anything, if we're willing to try, if we're willing to fail, if we're willing to look foolish. They laughed at the ice ship, but it almost carried bombers over the Atlantic. It almost changed naval warfare. It almost worked. And almost is closer than most of us ever get to building the impossible. At the bottom of a Canadian lake, the evidence remains. We tried, and that's worth remembering.